This video is for retake ticket for the system of equalities lesson quiz. So I'm going to go through these, how you're going to check your answers, also give you a little review. So we have two kinds of problems. The ones where you don't need to solve for y, and then there's ones later on that you do need to solve. So I'm going to go ahead and do a quick review. So to graph your line, you always make sure your slopes are as fractions. And most of you, the graphing of the line is not the issue. So 4x plus 3, I would go up 4 and over 1. But I'm going to have to go down 4 and to the left 1. It's less than, so it's a dashed line. And it's less than means underneath the line. So I make real light marks underneath the line. If you want to draw arrows that way, you can. Y is greater than, and again, write this as a fraction. So I point it to, I go down 1 to the right 1. It's worth checking. A lot of you missed a point by having the slope going the wrong way. It's dotted, and it's above the line. So my arrows are above this way. Well, the place where they cross is my answer. So I would go back and erase this extra or make the marks really light to start with. Okay. Second one here, I notice I have an equals. So 1/3 x plus 2 up 1 to the right 3. Greater than or equal to means it's a solid line, and we're shading above. X is greater than 3. X is vertical. So dotted. And then I'm shading to the right because that's the numbers that are bigger than 3. So the only place where my lines overlap is this little corner up here. Again, you need to go back and erase this other stuff so we know for sure that this is the part you want shaded. Y is less than or equal to negative x. I'm writing this as negative 1 over 1x minus 2 and 4 over 1x plus 3. Very similar to the first problem, only the signs are a little different. So minus 2, slope is negative 1. This is a solid line. Again, I'm going fast. You should use a straight edge. Less than means I'm under the line, going away from it. 4 over 1, I can't go up, so I'm going to go down 4. And this is dashed. And it is greater than, so it's above. So it's right here. And if you see this, you can stop shading because you know you're going to only use the part over here and erase the rest. Negative 1/3 x plus 1. Going fast. Dashed above. And negative 4/3 x minus 2. I can't go down 4, so I'm going to go up 4. 1, 2, 3, 4. And to the left 3. Nice. Negative. Solid. And above. Okay, so this one's a little tricky. So if I'm going above, where am I overlapping? So all this space in here has this double shaded area. And if you're not sure, like, I'm not really sure, kind of shaded here, I can pick any number out here and plug it in. So if I plug in, 3, 1, we can see if it's a true statement or not. So let's say I'm not sure about this little area out here. So I plug in 3, 1, and plug it in right here. 1 is greater than negative 1/3 times 3 plus 1. Well, that's negative 1 plus 1. 1 is greater than 0. Yes, that is true. Any point you plug in should work. Okay, now to the good ones. So for these, you have to be able to solve first. Some of you, I noticed, are skipping steps when you solve, and you're losing negatives. So let's just be careful about that. Show your work so you don't lose any negatives. I don't have to divide anything here, so I'm ready to graph. Negative 2, solid, under. Next one, x plus 2y greater than negative 2. Divide, divide, divide. Okay. Again, I didn't divide by a negative, so this inequality does not change. This is negative 1/2 x minus 1. Write the 2's under both of these so you don't lose something. So negative 1, down 1 to the right 2, dotted, dashed, and above. As long as you make the lines coming off at a right angle from your graph, you'll be able to see where the lattice happens, where the crossover is. So right in here, and again, you erase everything else that's out here or clearly make it dark enough. Special case here, y is greater than or equal to 1. That's a solid line. Y equals is a horizontal line. Talking about everything above it. 3x plus 2y greater than or equal to negative 4. Again, I don't have to divide by a negative, but I am going to write the 2 underneath everything. So negative 2. And then down 3 to the right 2, or up 3 to the left 2. It's solid. And I'm shading above. So right up here is where I'm going to darken in. Erase everything else. Now, one thing that didn't happen on any of these examples, if I would have had 3x minus 2y is greater than negative 4 instead of plus 2y, when I do the second step, and most of you are doing this, most of you are just making mistakes on division. But when I do this step, if I'm dividing by negative 2 here, remember this changes. Okay, last one, the special case, they're both have the same slope, negative 2. So I start at negative 2, slope is down 2 to the right 1. So it's the first one is dashed and above. Negative 2x plus 3. So I start at 3, I go down to the right one. You know the lines are parallel. This one's solid and below. So the answer is the part in between. If the lines are going the opposite direction, if one would be above, one would be below, the opposite would be above, and the other one would be below, it'd be no solution. So when you have the parallel lines, you either have them going this way or this way, that's no solution. You might have them both going the same direction. Just follow your same rules for overlap. Okay, the last two here, you don't need to make a graph to check the solution. You just need to plug in your number. And if I plug in this for x, plug in this for y, see if I get a true statement. Negative 12 is not greater than 10, so no, it's not a solution. Some of you are making graphs. You can do that, just not as fast. Negative 3 times negative 3. So negative 9 less than 14. That is true, so your answer would be yes. And again, I just plug that in for x, plug that in for y. That's it. When you have this ticket done, you can come see me and you can retake.